Hello and welcome to another tutorial. So this time we are going to be continuing to build on the spaceship controller that we've been building so far. So things we've done in the past, we've done the movement, working with the controller and the keyboard, we've done the different effects, set up systems for auto landing and auto leveling, and also made it so we can switch from being in first person character to also then switching over to controlling the spaceship. So what I want to add in this time around is start to look at getting set up so we can have health and damage and things like that happening for the spaceship. So I want things like impacts hitting into stuff to do damage, that damage to be based upon the strength of that impact, and then be able to have that have an effect on how the spaceship actually flies. So let's dive on in. So first thing I need to do with this is I want impact speed to affect the amount of damage, up to a point where, above a certain speed should just be critical damage and it just completely destroys the spaceship. So first thing, I need to get a sense of how fast it's actually hitting. So what I'm going to do is with the spaceship, we've already got stuff where we've got a rigid body, we are moving it in different ways. We don't have anything where we're doing anything with collision. So what I'm going to do is set up so that we can have a public, doesn't need to be public actually, but a void on collision enter. So this is going to run when a collision happens. So we get different information out from that. So a couple of things that we can see, we can obviously get stuff like the various contacts, but we also have this relative velocity, and that's the relative velocity of the colliding object. So the magnitude of that could be a really interesting thing to see. So what I'm going to actually log out is a debug log, and I will log out the collision relative velocity magnitude. And I'll also log out what it's actually collided with. So gameObject.name. So this will just give me a bit of a sense of the range of velocities that might hit. And that will make it a lot easier for getting a sense of, okay, what should my sort of minimum speed for damage to happen? Because that's the thing, we want a minimum speed that it has to hit with to cause damage, and we want a maximum speed. So that makes sense, 0 with the ground. And the player. So the player can run over and can get a reasonable impact. So we'll probably want to make it that the player, it can't be too much of a one. But now let's test. We'll get up to a height of about 80 to 90, and then we'll turn on the auto land. So I want to get a sense of, okay, the auto land, what is its sort of impact speed like? So in this case, because the ground's not moving, it's really going to be down to whatever our speed is. We should expect it to be fairly low. So yeah, one of about 2. So let's say if I go up to about an altitude of say 10 and I drop from here. That's about an altitude where I'd expect to have it cause damage. So we'll let it hit. This is about 14. Do that a couple more times around a similar sort of height. So we're looking sort of 14, 15 as a point where it should definitely we'd expect to have damage occur. Now let's go up to, let's say we fall from probably even only 50, a full fall at that from that height. So that's 31. So let's go up even higher. See what we sort of hit if we go to say 100. Hover a little bit. So now we're going to fall. It's 47. So I'm thinking around that sort of 30 to 40 mark is probably going to be a good point for saying, yep, it should have an impact. So let's now let it fall, and at about the 50 meter mark, I'm going to turn in on the auto land. turning on the auto land, so it tries to save it. So that 26, so that gives a decent sense. Because we want to know, okay, if we turn on the auto land pretty late, we should actually take a decent hit. So let's go for back up to about again. And then this time I'm going to turn on the auto land at about 80. So it's going to be a bit faster. And that's enough that it's going to easily drop it. But let's cut out the auto land. So again, so I'm thinking probably about 10 to 15 is our minimum point for damage occurring. So that gives us our threshold for, okay, how much we want to look at in terms of with damage stuff like of that. So I might put this up near the top. So header, health and damage. So we're going to say that min impact speed to take damage. I'm going to say anything above 10, it'll take damage. And we'll say max impact, or let's go impact speed for critical damage. And I think anything over sort of 30 is probably about right. We might bump that up to maybe 40, but I think 30, we can start off with it at that. So, okay, what we can then set is what is our amount of damage that we take. Actually, I'm going to go for that being 45 because I want to have a bit of scaling happen. So then that's the determining the range in which damage occurs. So then we have the min damage, which I might say the minimum damage that it can take is 1 point. Critical damage is easy. That's going to be our max health. So we'll have max health, which we're going to set at 100. I won't make that float. That will be an integer. So the minimum damage is going to be that. Then we'll be able to set our initial health. So our initial health will be the maximum. We know we're going to end up needing a current health, which we'll track further down here, but I'll set it up here for now. Int current health. So, okay, so far so good. I can come down here and I can set up, we'll make it public int current health, and I'm going to make this publicly gettable, privately settable. And that I'm going to set to, probably can't set it to our initial health, so I'm going to set it to something that's clearly invalid. And then in awake, we're going to say our current health equal to our initial health. So that's good. So now we can work out stuff here for taking damage. So that looks good. So we could also set up particular things that we can actually react to for taking damage. So we could set up, so we have a serialized field list string. And this might actually be, so we could do this different ways. We could have a set of tags to ignore, and we could have a set of tags to react to. I'm actually going to set this up with the tags to ignore approach. So what I would do is f tags to ignore contains collision, and we can't directly access the tag, but we can go to gameObject.tag. So ignore this tag. Then we might need to work out the damage. So we need to work out that relative speed. So impact velocity, we can take our calculation from here. Now, if the impact velocity is less than the min impact speed to take damage, we do nothing. impact too low to take damage. Otherwise, we then want to check, has it taken critical damage? So if the impact velocity is greater than or equal to the impact speed for critical damage, then we'll also return on, and we'll do an on spaceship destroyed. We might actually make that destroy spaceship, which at the moment won't do anything. We'll just log out. Need new spaceship. So, okay, we've handled that we don't take any damage. We've handled that it's taken critical damage. Now we need to work out the actual amount of damage to take. So we've got our impact velocity, we've got essentially our minimum and maximum speeds. So what we can do is, and our minimum damage and our maximum damage, it's going to be between those ranges. So what I need to know is where in that range between min damage and the maximum health we are. So I need the percentage between that, which I can map that to our impact speed. So this is where what I can do, this is one of the cases where an inverse lerp can be really handy. So the idea behind an inverse lerp is I would give it the min impact speed to take damage, I'd give it the one for critical damage and the impact velocity. And that's going to give me a 0 to 1 value. So impact factor. So that will give me that 0 to 1 value, which then I can work out the health by then doing a lerp. And I do a lerp from the min damage to the maximum health by that impact factor. So int damage taken is going to be that. Now, mathflerp can see it's getting grumpy at me because it's going to give me back a float when I'm trying to store that into an integer. So what I would do is a round to int. That way then whichever one it's closest to it will go towards. So now I can update the health. So the current health minus equals, except that could make it go negative. So, okay, current health is the mathf max of current health minus the damage taken and 0. That will avoid it going negative. We'll just make sure that's a 0. So we calculate the damage, apply the damage. Now we need to check because we might have been destroyed. So if the current health is less than or equal to 0, then destroy spaceship. So have we been destroyed? So if we've been destroyed, what we will do is, because we've already got this stuff for this attempt to exit vehicle, and let's take a look and see how this actually gets used. So we can see the input dispatcher will go and do that, and if it can exit it, then it goes and does this. We could make it that it does a force exit. So this is where a good use of setting up for events. So I'm going to do using a Unity engine events, and we will have a serialized field Unity event on spaceship destroyed. That's a new Unity event, and we'll invoke that here. So we invoke the event, and then we're going to do a destroy of this game object with a very slight delay. Just so we've got a little bit of a chance to actually perform the switch. We'll set up a function here, void on spaceship destroyed. And we'll do a force of the target changed. And that looks pretty good. So with that, we can also just check and make sure. So it does have some stuff here for working out the position. I am going to say that what it needs to do at that point is it's going to have to actually force the player to a particular location. So we would have the player controller transform position is equal to the spaceship's transform position. So it's just going to position them where the spaceship is, and then the spaceship is getting destroyed. So that should be pretty good. We might actually not even need that slight delay. We'll test it and see how that goes. But that should mean it then gets destroyed. What we would then do is there's a lot of things here that would actually just never be able to update then if we have the no spaceship. So that's something where we would need to potentially do some updates there with that, because things like being able to enter, exit, likely we won't ever actually be able to do that because it's not going to be near enough, but something to be aware of. We'll find those issues momentarily. So what I'm going to do is with the spaceship, when it gets destroyed, I'm going to have it talk to the input dispatcher, and it is going to run on spaceship destroyed. Now I will set up some stuff here so we can log out. Current health is just because we're going to want to be able to see that. So let's find out. What happens is if I drop from, say, a height of 15, now I don't have it ignoring the player yet, so I'm going to make sure I set that up in terms of the tags to ignore. I'll make sure it ignores the player, just so that the player running into it doesn't cause damage, because the player is definitely going to need to move towards it. So cool, we don't see damage prompts appearing, which is good. So now I enter it. So let's get to a high enough height that we should expect to take some damage. So about there's probably good. So we lost 21 health points. If I go up way higher, so we'll go up high enough that it's a case of it's going to be instant death. This is where we'll find out how well this works in terms of just kicking the player out of it. So, okay, that worked, but we did get a error, which is to be expected. So this is something where we know then we need to update things like of this. So this is something where if the spaceship is gone, we can't actually go and do anything with this. So I'm going to keep track of here. Full spaceship alive, which is true. Don't really need to keep track of one for the player because that's something where there's no way that the player can't be alive, at least with the current setup that we've got. So what this would mean is stuff like if this, we only work with these if the spaceship is actually present. Now the HUD we can always change because the HUD is safe to, but the camera, because that's on the actual spaceship, We could look at other ones here in terms of, okay, if it's trying to change the target, we would have to look and see, okay, well, where is it setting that requested target? So this would be something where enter vehicle, F, spaceship is not alive, we return, we just can't enter it. Exit is fine. That's something where we won't be able to switch back to the player. So that should make it a little bit safer. So now if I go and do this and I'll let it drop from a massive height, so it'll take critical damage. That should do the trick. So we'll just fall. That'll definitely do the trick. So we're going to hit pretty fast and we just get kicked out and we don't have any spaceship. So that's good. We've got our behavior happening there quite nicely, which is great. So there's other things we want to do with this because we've got our HUD. So let's make it that our spaceship HUD is actually showing information like our health and everything. So this, we need to go and update our HUD here. So our instruments, we are going to add in a health display. So different locations of where we could choose to add this. We do want to have it be something where it is reasonably central, where it's fairly clear what's actually happening. So we've got our instruments is something where people are going to be fairly heavily focused on that, which is good. We do want them to be fairly focused on that. I'm going to actually create a new panel for this. So this is going to be health and damage, because there might be other information we want to convey with this. So I don't want it to be taking up all of that space. I want it to be about the same size as the instruments panel. So I'm going to have that span, going to set the height like that. The anchors, we'll anchor this at 100. So that looks pretty good. I'm going to use the exact same setup of background wise. So that looks pretty good. And then in terms of how we want to indicate the health, different ways that we could go about indicating this. So one thing that I could do is if I added in something like just an image. And if I make this so that it's sized like this, so then we could mess with this and see, okay, if I mess with like the X scale, that actually works pretty well for giving us a health bar. So it can decrease things like of that. So I think we'll use that. So we need to then add in a serialized field, a rect transform, health bar, and we'll link that up. We might actually make that health bar transform, and we'll go for the Unity UI image. So this will allow us to adjust the tint of it. So health bar. Now we could actually just from that, because we would be able to go health bar transform. So we might actually just link it to that. That'll make it a little bit easier. And we'll bring this in as a using up here, just again for consistency with everything. So what I might set up is a gradient health bar color, because that will allow me to set up a gradient that I can just query with a 0 to 1 value to get the actual health information, which that will be really handy. So this, well, at 0, we are going to make that a red. I'm going to make it a slightly pale red. And then we'll do a similar thing where we'll go for a slightly pale green. So that looks good. We'll update our prefab there. Always good to make sure you remember to update the prefabs. Really, really easy to forget. So I want my health. I've got it there as just an integer value, but it'd be much handier if I had this as a 0 to 1 value. So health percent. And this can just map to, we can do current health divided by float of the max health. Just makes it much easier, because then what we have here is health bar, and its color becomes health bar color evaluate. And we can say, well, linked spaceship and the health percent. We can also see health bar, its transform dot local scale ends up being a new vector 3. We use that health percent, and then we keep the others at 1, which should mean we have a health bar that will adjust in size and scale as we take damage. And I might actually reduce the height of that. I don't think it needs to be that high. That's a better height, I think. Again, remember to update the prefabs. So now let's test. What I would expect to see is that changes to a greenish color when I'm in the ship, which I am. If I get up to enough of a height where it'll take damage, it shrinks, color has changed a bit. Do the same thing again. More damage, more of a color change. Bit more. So again, we've got something, and by keeping it centered, so something to always keep in mind when you're setting up user interface, setting up anything visual in a game, you want to manage the player's attention and think about, well, where are they going to be focused? Because if they're going to be focused in a particular area, and with the spaceship, that lower part of the screen is going to be a major area of focus. So if there's critical information they need, put it there. And in this case, we are using color, but because color is something that is not going to work for everyone, we also have the shape change there, which means that it's something that's going to stand out a bit clearer. I would actually increase the darkness of the area around it, just so that that bar again stands out a little bit more. And I might increase the height of this so that it's just going to stand out a lot clearer around the surrounding area for folks. So that's good. So we can take damage. Let's have other effects though. And so there's a couple of things I want to do to this that are going to allow us a little bit more control. So one of the things is I am going to set up an animation curve. And this will be the damage curve, particularly the impact damage curve. Because we've got a linear thing between the two, which might be what we want, but we also might want to be able to vary that. So if I run it through an animation curve, I can then adjust the shape of that. So I could make it that the damage penalty increases very rapidly, very slowly. I have control over it then. So I could still keep it linear if I wanted to. So I can absolutely just set it as a linear thing. This will behave exactly as it did before. But if I want to vary it, if I want to make it that at lower speeds, it actually is a bit more forgiving. And it's not until we get right near the end that it's going to do a lot more damage. That's something that I'm able to do with this. So it gives me that flexibility, which is good. What I could then also do is set up stuff here where we've got our input, everything like of that. So one of the things that I would like to be able to do is have it that the damage is going to determine how well the engines work. So the more damage we've taken, the more the thrust gets reduced. So that's something that's not going to vary linearly. I want to have an animation curve for that. So thrust impact versus damage. So increasing damage will be able to have an increasing impact on the thrust. So how I would set this up is if I did something like this, then at fairly low values there's still going to be an impact, but I actually want it to have to have at least 50% damage before it has any effect. So I'm going to make it that we'll set the left tangent to constant, and the maximum here as well. I might not want it to ever get to a point where it fully takes out all of the thrust impact. So I'm going to say that the maximum value there is actually something like 25%. So we're going to lose a chunk of our thrust, but maybe not the full amount. We could adjust the curve here for how quickly that happens. So we've got different options there. Well, actually, initially just for testing, maybe 50% we could lose. It's going to be pretty linear, but then caps out. So then what I want to be able to do is these maximum forces, which I want to check that those line up with the values, because I need to actually make it that these, easiest way to make these changes is to break the code so that I can spot all of the areas where these get used, which is auto landing, things like of that. Because then I can set up, and this is how I'll normally do changes like this. I would set up a protected float max V force, and then that is going to be the variable that was already set up. So the ones that we've got here. So that's going to be max V force. But if we think about this with the curve, so let's make it that we're evaluating the curve. And again, I can set up some helpers to make this a little bit easier. So I could have a thrust impact from damage that is going to use that curve. That has to evaluate. Now, it's not the health percent. If we do 1 minus the health percent, that is actually our damage amount. So if we're at 100 health, then our damage is 0. So that's going to map quite nicely to that. So then our maximum vertical force, we know our curve here, the value represents how much this gets reduced by. So we can multiply this by 1 minus the thrust impact from damage. So if we're at really high damage, that thrust impact from damage will be about 0.5, which means it'll reduce it quite a lot. Otherwise, it's only going to reduce it a very small amount. And then we do the same thing with the H force. So now, our ability to do things like auto landing in that is actually going to be impacted by us having taken damage. So if I get here, and first thing I'll do is we'll enter the spaceship, and I'm going to cause a bunch of damage. So, and that's, you see there it took less damage. That's because of those changes we put in so that it's running through the animation curve, which is good. So that's working as intended, that we've got a little bit more leeway with being able to do damage to this, which is great. So I'm not yet at 50% damage. I would now be at a point of 50% damage. And I definitely am noticing that there is not the same level of thrust. It's taking longer for the spaceship to be able to take off, which that means, and we really can see it now as that damage is ramped up, like the thrust impact is going much higher, which means we're actually going to be less capable of doing things like auto landing. So if I get up to a height like of this and turn on the auto land, it's going to be able to just do it, but it is definitely a lot more of a struggle. And just taking off is harder. Our ability to move around is a lot less because of that. And if we take a bit more damage, we hit the point where we just can't actually manage to take off because we have received that much damage. And this is a fairly simple effect. You could also do stuff where it starts to mess with the directions. You could take off things like the auto landing. So above a certain damage threshold, you could actually make it that they can't auto land. You could turn off auto leveling. So there's a lot of different things there that we could actually turn off that are going to make it so that we have different effects. It really depends upon how you want that experience to be for the player. That's sort of the guiding aspect with that. So, okay, we've got it so that we can take damage. We can see that those damage has effect. It would be nice if we could actually repair the damage. So let's take a look at what we've already got. So we do already have stuff where we have these things for attempting to enter the vehicle. And that checks a couple of things like, is it actually looking at the spaceship? So we could also set up some stuff here where it's trying to repair the spaceship. So what we could do, we could actually use this, is we have, in terms of our inputs here, and it'll be the input dispatcher will receive the stuff. So we can see it receives stuff like primary action, things like of that. So we should have if we go to our player controller, so we'll bring up our, not print, we'll bring up our character motor. We can go to where we have our primary action. And so that's for trying to send UI interactions, things like of that. But we could also then check here, well, F input primary action. And this could then do some repairing. So this, we don't want that kind of interaction. We could use our max interaction distance would actually be a valid one here. So we've provided the primary action. We can check if we are looking at the spaceship. Then let's just put out a debug log, attempt repair. Because what I want to just see is that coming through. So I could set up a bunch of other things for doing the repair already, but I just want to make sure that this part works first. That's what's important. You really need to always make sure you're testing stuff at the earliest possible point. So I wander over. And so I don't get there anything from doing the primary interaction. So that's something where, and this is why we do this test early. So we want to actually check, do we pick up this? So we can set our breakpoint, can attach to Unity. We just want to make sure that it's actually coming through. It could be that the distance is too far. There's a lot of things that could cause it. So it does run into here, which is good. So we're going to run up really, really close. So constructs the ray. It does do a raycast out to that distance. And we can see what it hits is that. So it does hit the spaceship, but you can see that it's checking to see if what it hit was the this particular spaceship, so the one that it's actually run on, which is not correct. So we just want to check, has it actually hit the spaceship? So we would go for spaceship controller. And this is where I don't think we have a try get component in parent. So I don't think there is a try, there's not a try get component in parent. So we have to do this way, which is a little bit not ideal efficiency wise. It is a bit more expensive than if we're able to use the try get component one. So if there is a spaceship controller, if that's not equal to null, and the spaceship controller, or let's go for can be repaired. Again, I could check the health and things like that directly, but always good to put these things onto the actual thing that you're interrogating, because this is something where we might want to in the future have other things that are happening that might affect the result of this can be repaired. So it means we can keep it all contained within the spaceship logic. So F can be repaired if the current health is less than max health. What that should mean is I can walk up to it, and at the moment it should say nothing, because at the moment I actually can't repair it. So if we go here, go to interact, nothing, which is good. I enter it, and I'm going to cause some damage. So cause some damage. So now, if I go up to it, then it says attempt repair. So that's good. We've got feedback. We can have it that it only is performing this when it should, which is great. So our character motor here, if we look at the different things, so we can say that, yep, input primary action, that's going to update. Now, one thing we want to check is what happens if we hold down the button while this is happening? Do we continue getting ones? This is going to affect what we actually do with this. So enter, cause some damage. Taken some damage. So what I want to check is, okay, if I hold down the mouse button, we just get the 1. So each time I'm just getting 1. Now we could check and see if we get something, on the falling edge of this, but likely the primary action, we may only be picking that up when it's actually true. What we can do is debug log value is pressed. This will just give us a sense of what we're actually getting output-wise, because that's going to change how we structure this. And it might mean we need to make some changes to the input system side. So always good to do these tests. So we get true. So we're only getting it on the rising edge, effectively. So let's take a look at our input config. And so with the player, the primary action, so we can see it's set as button. And what we get, we could interaction-wise, so with press, we could set it that press only is the default. We could say we want to get press and release. So let's test now with that and take a look and see how that behaves. So press it and I release it, so we get both. So that's good. That allows us to send through, start, stop things, stuff like that. Okay, so we've got it. So we've got start and stop messages, which is good. We need to sort of work out how we send this stuff through, because obviously if we are repairing it, we need to keep looking at it. So there's bits there that we need to be doing with this. So I'm going to set up, so we'll have spaceship to be repaired is null. Doesn't strictly need to be set to null, but force of habit. So we'll do this. where what it will then do is spaceship to be repaired is that. So now we've got that set. If that primary input action is not true, we want to check, well, spaceship to be repaired, that's not equal to null, then we need to be able to say spaceship to be repaired, stop repair. So that's good. We could conceivably have multiple spaceships that we're looking at. So if spaceship controller is not equal to the spaceship to be repaired and spaceship to be repaired is not equal to null, then we're trying to repair a different spaceship. So we do spaceship to be repaired, and we'll do the same stop repair. So this is the case for if the spaceship has changed. So spaceship changed. And then this, we can do spaceship to be repaired. We'll do a start repair. And then I'm going to take this, and what we will do down here is spaceship to be repaired is equal to null, so we make sure we clear it. And then down in our update, we are going to check if spaceship to be repaired is not equal to null and input primary action is true. Then we need to check if we are looking at it. Are we still looking at the spaceship? So we need to check that the spaceship controller is equal to this same one. So that must be equal to that. So I'm going to set up here a bool tick repairs, which I'll default to false, and I only set it to true in this case. Otherwise, what happens then down here is if tick repairs is true, then that's all good. We can go and continue to, so we'll do spaceship to be repaired, tick repair. Otherwise, we cancel it. So we've looked away, so we stop the repair, and we set that to null. So we tick or cancel the repair. So it's one of these things when you're having to do these sort of hold interactions, it does end up resulting in a lot of extra little bits of code you need to add, and they can be pretty fiddly. So just something to be aware of. But it means our spaceship now has functions here of public void, start repair, public void, tick repair, and a public void, stop repair. Now we really only need the tick, but the start and stop would allow us to go and update stuff if we needed to. So we could kick off different effects, things like that. So what I'm going to do is that tick repair, well, we need a repair rate potentially. For now, I'm just going to log out, start, tick, and stop, just so we can make sure that these are actually happening correctly. Because before we set up a bunch of logic, we want to make sure that it's actually happening correctly. So we're going to wander over, cause some damage. Good, so then we can exit. And with it then exited, what we're going to do So we've caused some damage, we've exited now, we can go over. Click the mouse, we can see all the ticks, and then we can see stop. If I start again and look away, we get a stop. Start again, move away. So that's good. We've got all the information we need there for making the repairs happen. So we need to think about how we actually want to tick up changing of the health, because the repair also should potentially stop when it's actually finished repairing it. So I might make it that tick repair can return a result, and it returns true. So what we would say is if the current health is less than max health, then it will return, actually I'll make it current health is equal to the max health. So it returns true when it's actually done, because what we could do then here is can tick the repairs like that. And then I could do something where what I say is if tick repair returns true, then I would actually, so it will return true when it's finished, then we can actually stop the repairs. So this is something where, okay, this if setup here is a little bit messy, we could absolutely clear that up. So we could make this that if tick repairs is true and this, then we run the logic, or not tick repairs. So gives us a bit of a simpler setup. So tick the repairs. And so what we're doing is we clear the spaceship if repairs complete, or if could not repair. So that should work. So if this is true, it'll run this. Otherwise, if it wasn't true, then we'll be able to cancel out. So, okay, good so far. And it's actually making the changes here, because our health, if we think about it, depends upon the rate that we want that health to go up. So if that health went up, because we're, say, getting ticked 30 times a second or 60 times a second, potentially, which means if we did like 1 point, that's going to zoom up really rapidly. If we do less than 1 point, well, it's an integer, so it might not ever actually repair. So what I need to do is I need to actually be a little bit sort of tricky with what I do with this. So what I could say is the repair doesn't get applied potentially until we have enough to sort of carry over is one option. So it does make it a little bit trickier for how we actually manage this, because we want to be able to control the repair rate. So I want to be able to say repair rate. So it repairs this amount of points per second. So I think something like 10 points per second is reasonable. What I could then do is down here is where this thing gets a little bit tricky. So repair amount is, okay, well, we do repair rate by time dot delta time. But that repair amount, unless that's greater than 1, we can't really do anything. So what I would have is a hasted repair amount is 0. And specifically, when we do start repair, we set that to 0. Then I update that like that. So then if the hasted repair amount is greater than or equal to 1, then we can apply particular amount. So we have health to add is a mathf floor to int of cached repair amount. And then I could say current health is equal to the min of current health plus health to add and our max health. And then the cached repair amount, I subtract that partial amount. So this is a way of having it that it can still tick it up, but it's not going to update it until there's been enough where it actually will make an integer change. As soon as there is, floors it, adds that, and then we can perform the rest of it. So that should do the trick. So I will have stop still there. And we'll make sure that in the character motor, we do the stop repair and everything. So let's cause some damage so that we can have to repair it. So I'm going to run over, go flying up a chunk, take some damage. Let's cause a bit more. Let's make it that we've got a fairly decent amount of damage that we need to repair, so at least takes a little bit of time. There we go. Now we're talking. So we need to repair this. So I can go over to the ship and start doing the repairing. Now it should be doing repairing, but we don't have the feedback anymore. So this is something where we saw a stop there, but did we actually, and it did repair, we don't have any indication of that progress. So what I'm going to do is make sure that here, when we're actually doing the repairs, it might be useful to always see that HUD potentially. Or what we can do is, we're ticking the repairs. So I'm going to say, while it's ticking the repairs, which we have that happen here, that we'll do spaceship to be repaired, health, log out the current health, just so we can see this, because this will let us know that it is actually ticking. We'll be able to see the rate that it's ticking up at. I'm also going to start the spaceship just for this test to make it a bit easier at 25 health. That'll just make it, we don't need to go and actually crash the ship. So we wander over. So we saw a stop. And so we're seeing that, but we're not seeing the output. But it has definitely repaired some of it. So what we want to do is take a look and see what's happening in the spaceship, because we're doing that cached repair amount. We're doing this logic. I want to make sure that it is actually properly adjusting this so that we can see what's going on. And it might be that it's just making such a large change. So we run that. We've got the health to add, so cached repair amount has gone up. The health to add is 1. So our health goes up to 55, which is good. So that's worked. In the debug log, we put it in the wrong location, which actually, yep, that will do it. So what I'm going to do is put this into here so we can actually see this happening. Will be a better visualization of it, and then we can look and see about having an actual display. So that looks good. So we'll run this, can wander over, can see it's ticking up at a pretty decent rate. We stop. We can resume at any point, and then when it hits max, it also stops. So that's good. So we know our repairs are working. We know that that side of things is actually happening, which is great. What we could do is we could have a visualization, a bit of a HUD that appears for the player. So I'm actually going to change this around to, I'm going to bring this back like this. Tick repairs in that is done. What I can actually do is, if not tick repairs or spaceship to be repaired, can be repaired. So if or it's not able to be done. So perform repairs. We could then have a visual indicator. So we could actually have a little bit of HUD that appears for doing the repairs. So we already have a bit of a player HUD. So we could have up here a bit of text, which I'll move this text. We do want it centered like that. And what I could indicate is the repairing. So we get a bit of a sense of the size that we need for this. We'll align everything in the center, make that width more like 300. And I will put it so that it is below the actual reticle. And I want to make sure that it does not have raycast target enabled. I don't want it to be a raycast. So this is the repair text. So what I would be doing is repair. We'll have a setup where we can link this. So we have serialized field, protected. So using TM Pro. So have Text Mesh Pro repair HUD. And then what we do is down here, repair HUD, text, and we can make that to be repairing. And then what we do is we grab our spaceship to be repaired and its health %. We'll multiply that by 100. And I'm just going to make this a mathf. We can do this as a round to int. And we'll display the % like that. Now, whenever we do a stop repair, we can do repair HUD. And we can turn that off. So game object set active false. So we don't need that to be on. So whenever we have a stop repair, we want to make sure we do that. Just so that it's not lingering around. So we just turn that off in those cases. That's good. And then in this one, we want to make sure that it is actually enabled. So we do repair HUD, game object, set active to true. And what I might do is only do that when we do the start repair. So we can do that where we only do that during start repair, but repair HUD text in that case, I'm just going to make it empty. So this should mean we get our repair text appearing. I'll need to link that up so the player knows about that text. So that's something where we go down the bottom here, we can link that up. And that text we can turn off by default. So when we head over to it, we should actually see then that we can see it should be repairing, but we're not seeing the text. Now that repair text did get enabled, but you'll notice it didn't get turned on there. And if we take a look at where we go and set that to active, so it did get turned on, its text got set to empty, and then down here, it's only doing that in that case, so we actually need to do this. So now we should see the percentage. And that's what we're looking for, is that percentage ticking up. And I just got that feedback. We could also then start using that for displaying other prompts. So things like, indicating what's happening. So you can see the repairing. We stop, keep going. As soon as it hits 100, then it's back and we get the stop. So we can just remove our little bits of debug because we don't need these anymore. But that gives us our spaceship that can be repaired, can take damage. That damage can have different effects. Just make sure we update our prefab so everything there is back to normal. So that's good. And again, with this just being cautious, we're only applying the prefab to the essential bits, not applying it to everything. But we've got our spaceship, we can take damage, it affects things, we can repair that damage, and we've got visual indicators for that damage and for the repair progress that we can be making use of there. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you've got any questions, chuck those in a comment below. If you're looking for the code, that code is available up on GitHub, and I've put a link to that in the description below as well. You can use this code in any of your own projects, commercial, non-commercial ones. It's free for you to be using there. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below as well. But until next time, bye.